900 rated question for today. So the question says that you are given an unsorted permutation and we need to sort the permutation. You can choose any constant k and do this operation. The operation is that you can choose any index I and j such that I minus j is k and then swap the elements at I and j. Find the maximum value for which you can sort any permutation. So let's write down the given things. So first of all, some definitions if you don't know. A permutation is an array sequence where there are all integers present from number 1 to n. So a permutation of length n will have all the integers from 1 to n, not repeated, and it can be in any sequence. An unsorted permutation, as stated in the question, is where at least one index is not at the position it is at. At least one number is not at the same position that the value is. That is, let's say there is, uh, I'll give an example. Let's say this is an array 1, 2, 3, 5, 4. This is an array. And this is also a permutation because this is an array of 5 integers containing all 1, 2, 3, 4, 5 numbers, right? But this is unsorted because the number not at position 5, right? The number 5 is the not at, these are the positions I've stated 1, 2, 3, 4, 5. All these numbers, 1 is at position 1, 2 is at position 2, 3 is at position 3. But 5, the number 5 is not at position 5, it is at position 4. As this one of the indexes is not matching, so this is an unsorted permutation, right? So we need to find a k. What is k? K is a constant. K is a constant number and it defines that the distance between the two elements which we can swap, right? You can swap any elements at a distance k from each other, and using these swaps of k distance we need to sort an unsorted permutation. So let's say this is an array and let's say k is equal to 2, right? We can swap elements at a distance 2 from each other, so we can swap 1 and 3, like this is distance 2, right? So we can swap these two elements, so 3 comes here, 1 comes here. Likewise we can swap these two elements. Okay, so using these swaps we need to sort the array. So to find the answer we'll just have the fun with some problems, like what happens when we swap and what all facts we can derive. Okay, so let's say for a particular k, okay, I have fixed k as k is equal to 2 and this is a general array. Let's say this is a general array and we choose an element 7, a7. Okay, so how many swaps we can do? I mean, where all can this element be swapped to, right? As k is equal to 2, this can move 2 distance, right? So it will move from a7 to the position of a5 and a5 will come here. Likewise a7 can move to all these positions as I have marked, at this a fifth position, at third position and at first position, right? It can also go towards the right from a position of 7th position to the 9th position, from 9th position to 11th position, right? Similarly, let's say we need to see where the a4 element can go. A4 element can go to the 6th position or the 8th position or the 10th position, and if it goes to behind, it can go to the 2nd position as well. So what we can observe is that a particular element can move a distance of k from its initial position, right? It can move a distance of k, and we need to perform such swaps to make the array sorted. That's what the question is. So this is what we have found out, that for a fixed k each element each element each element can move a distance of k, a multiple of k also, right? N times k. It can move any multiples of k, uh, ahead also and behind also, okay, in the front and in the back. So mathematically, if we go and note it down, let's say this is an array. So in this array, I have marked down the positions of these elements, like this is an array 1 to a1, a2, a3 and all. These are the positions, that this is the position 1, a2 is present at position 2, a3 is present at position 3, likewise, okay. So these are the positions, and let's say that this value a1 is a value, right? This is the position 1, and at that position there is an element a1. This a1 can be anything. It is not necessary it is 1, like as it is an unsorted array, so it can be anything. Let's say this is 5, okay. So if this is 5 and the position is 1, so this, to make it sorted array, we need to make it such that this 5 should go to position 5, right? Yeah, it will be a5 and 5. So we need to perform a swap such that this element a1, which is equal to 5, should go at position 5 where the element a5 is present, right? So let's say that this distance that it needs to move is d1. Likewise, these are all the distances, right? d1, d2, d3. These are the distances that a particular element must move to match its position, because matching its position means it is being sorted, and it is an sorted array, that the first position will have the value 1, the second position will have the value 2, the third position will have the value 3, okay, likewise. So that means for each index I, that is 1, a1, a2, a3, the unsorted position will be, like, as I said, that this was the number 5, right? The number 5 is at position 1. So in an unsorted array, in this array, the element 5 is present at position 1. So unsorted position 1 is equal to a sorted position. In sorted, the element 5 will go to the position 5, right? So I just noted down. In this case, for the element 5 is present at position 1. It will be equal to the sorted position. After sorting, it will be at position 5 plus minus n times of k, right? There will be a k, such we need to find a k, maximum k, such that for each index all these conditions hold true. That for, you can imagine it, right? Like imagine there is a wrench where there is a fixed wrench, so we can swap all the elements using the same wrench. As in the example I had 2 there, let's say it was 3, so we can swap any elements from a distance 3, right? Any distance 3 element we can swap, okay. So for all, that means the k is fixed, we can swap the distance which the elements are swapping, that distance is fixed. The unsorted position is given to us using the initial array. The sorted position is defined to us because we know that after sorting, the fifth element will be at the position 5. The number 5 will be at position 5. We know this for a particular array. We have to find a k for a particular array. Then this n is varying, right? N is varying according to these conditions. According to these conditions, n is varying. So that is what is being said, that unsorted position is equal to the sorted position plus or minus the nk. That means, basically in simple terms, you can say that if element 5 was in position 5, that is sorted position, if we do plus minus nk, if we do jump, right, any number of time, let's say an element 5 was at position 5 and k is equal to some 3. So k can move 3, jump in multiples of 3 forward and also in the multiples of 3 backwards. So that is what I'm mathematically saying, that the sorted position plus minus k multiples jump ahead, in front or in backward direction, will be its unsorted position. This will be given to us. The array with unsorted positions are given to us. The array and sorted positions we know. Okay, so rearranging it, when we uh, take this to the left hand side, the unsorted position minus the sorted position, let's say, as in this case the unsorted position was 5, sorry, the unsorted position was 1, and after sorting the element 5 should be at position 5, so the sorted position is 5. So the difference between this is nothing but the absolute distance between where this should have been. We know where this should have been and we know where this is, so we can find the distance. So that is the absolute distance, right? The absolute distance will be equal to a multiple of k. It will be a multiple of k. Therefore, let's say what all is there. K, for a particular array, we have to find a k which will be fixed for an permutation. We need to find such k. And for a permutation, there are n number of indices, right? There are n elements, so there will be n indices, and for each indices the absolute distance will be different. Like here the distance will be d1, for this element the distance will be d2. Therefore there will be different distances, and according to these distances the n will vary, because k is fixed, right? And we have to find this fixed k, which is the maximum that is possible. So what this means is that for different distances we need to find a common k, and the k should be maximum which is possible, right? Because the question says the you need to output the maximum value of k that can sort the permutation. So for all the distances you need to find an integer k which has, that is GCD. You can see it's a GCD. The GCD of distances is k, right? Because let's say element a4, which is 8, right? So it should be at position 8, but it is at position 4, so the distance in this case is 4. Let's say an element a2 is 6, so after sorting this element should be at position 6, right? So the distance the distance for this is 4 again. Let's say I'll change it for a bit, okay? Let's say a8 is equal to 10. So after sorting this element number 10, the element 10 should be at a10, right? Position a10. So it should be at the 10th position. So distance, the absolute distance it is from the sorted position is 2. So these are the distances, 4, 2, 2, 4, 4, 2, right? So these distances we can move, like a4, a8 and a2. a2 needs to move a distance of 4, a4 needs to move a distance of 4, and a8 needs to move a distance of 2. Okay, if a8 needs to move a distance of 2 and these two needs to move a distance of 4, can we say that instead of directly moving from distance 4, it can make a distance 2 too, that it can break its journey? Because that's what GCD is, right? GCD of 4, 4, 2 is 2. That means a journey of 4 distance can also be made using the journey of 2 distance. A distance 2, a distance 2, a distance 2, and a distance 2. 2 jumps of distance 2, right? It is possible. So that's what the problem is, that we need to find the GCD of all the distances. if the distance is 0, right? If the distance is 0, that means the number is at the correct position. That means if the number is 5 or 4, it is at the fourth position. So a1, a2, a3, a4, the fourth position, the value at 4 is 4. So this is at the correct position, and for this the distance is equal to 0. Distance equals to 0. So there is no need to jump this number anywhere. There is no need to swap this. And for all the rest numbers which needs swapping for them to be sorted, for them to be at their correct positions, we need to find the GCDs of all those distances. Okay, I think you have got the solution. So that is it. We'll find the distances. Let's say this is the question, right? Okay. This is the question. We'll do this test case first. We'll see this test case. Okay. So this is a permutation of 10 elements. Okay, I'll just write down the position. This is 1 2 3 4 5 6 7 8. These are the positions. Okay, now what are the distances? The element 3 should be at position 3, but it is currently at position 1. So what is the distance? The distance is 2. Similarly, for this element 10, it should be at the 10th position, but it is at the position 2. What is the distance? The distance is 8. Similarly, absolute distance. Okay, that it may be possible that this number is smaller than this number, or this number is smaller than this. We need to find the absolute distance. That is a positive distance. So for all other values, I'll just note it down. Okay, so these are all the distances. That means each element needs to move this distance, the distance above that I have written. The element 10 needs to move a distance of 8. The element 9 needs to move a distance of 4. So to make these journeys, we need to find the maximum k, that is the maximum jump that is possible. So it is nothing but the GCDs of all these numbers which are positive. Don't mind the 0, they don't mean anything. So all these numbers, we need the GCD of these. So in this case the GCD is 2. So this journey can be made possible. This journey can be made possible by by a jump of 2. That means 4 jumps of 2 is required to make the distance 8 covered. Okay, let's see if that's the answer. Last second test case, right? Last second test case has an answer 2. Yes, the logic is correct. That we need to find the GCD of all the distances. You can see the code right here. I have first unit, as we don't know how many integers, when we find the distance, we don't know if it's 0 or any positive value, right? And we need the GCDs of all the positive values only. So I have used an array list instead of an array, because array is used when we know the number of elements, but in this case we are finding it out as we go. So I am using an array list, and when the distance is positive, I am adding the distance to a distance array list named D. Okay, and I am finding the GCDs of all these arrays, of all the elements in the distance array list. And this is the GCD function. Just note that in this case earlier I used p, if p should this will run until either one of them turns 0 or any of them or both of them turn 0, right? So one thing I did was, instead of using this, I used that if p times, let me show you, if p times q equals to 0, right? So if either of them turns 0, then this holds true. But what happened was, as this p and q were elements, right? So it was the elements are from 10 to the power 5, 2 to 10 to the power 5, right? So 10 to the power 5 times 10 to the power 5, which was 10 to the power 10, and I used integer, so there was a data overflow. So instead I was getting error. I spent a lot of time debugging that. So instead of I tried the clever way, right? So instead you need to use directly p should be greater than 0 and q is equal to q should be greater than 0. Okay, thank you, that's it.